For part A, we're just looking to find the area of that region. And so we can see that it should be an integral from 0 to 2 of the upper function, which is just 6, minus our lower function, or natural log 3 minus x. And with any luck, you evaluated that out. And what did you get?
6.817 units squared.
All right, 6.817. Perfect. So a couple of things to note. First off, anytime you are doing a free response question using a calculator, never round to less than 3 decimals unless it explicitly says to. So always round to 3 or more. If you had made this 6.82, you would not get the points for the answer. All right, so this part A was worth 2 points technically. So 1 point for the answer and 1 point for having the right thing inside your integral here. And it also says that you got 1 point if you had the correct limits of integration, so 0 to 2. 0 doesn't really look like a 0. In any of the problems from A, B, or C. So we would have got 1 point for having the right limits 0 to 2 there. So we would have already scored 3 points, so not bad. All right. If we're looking at part B, B wants us to find the volume of the solid generated when R is revolved around the line y equals 8. So if we're going around the line y equals 8, and we're going to go, we're going to go around it, around the horizontal axis, we should slice it vertically to give ourselves washer cross sections. And our outer radius should be from y equals 8 to our function here. And our, we'll call that outer radius. And then our inner radius should be the distance between 8 and 6. Everybody agree with that?
Yeah.
Okay. So pi times the integral from 0 to 2 of your outer radius. Well, our outer radius is, like we said, from 8 to the function. The function here is y, right? It's this 4 ln 3 minus x is that distance. And so the full thing is 8. And so capital R ought to be 8 minus 4 ln 3 minus x squared minus, and then what's our inner radius? It should be the 8 minus the 6. It should just be 2 squared dx. Or if you just write a 4 there, that's fine. Or if you put 8 minus 6 in parentheses squared, that's fine. And you have 2 points for getting this correct. And what did your answer come out to be for that one?
168.180.
Perfect. So that was your answer, and that was worth a 3rd point. And if you hadn't got the right limits, 0 to 2 up here in the first one for some reason, but you did have them in part B, you would have gotten that point from part A down here in part B. Everybody good there?
Yeah.
All right. And for part C, we've now got the region R is the base of a solid. Each cross section perpendicular to the x-axis is a square. So if the cross sections are perpendicular to the x-axis, what variable are we going to do this in terms of?
Y.
No.
Well, in terms of
What is the thickness of this square? If this is projecting out of the screen at you, the thickness of it is
dx.
dx. So we're going to have to do this in terms of x, which means we're still going to integrate from 0 to 2. If there's squares, it should just be the side length squared. And what is the length of this side here? Should be the upper function minus the lower function. And so that should just be 6 minus 4 ln 3 minus x. And since it's a square, the area should be the side length squared dx. 2 points for having this correct. And then 1 point for getting the right answer. And what did you get for your answer?
$26.267.
Sounds good to me. And so that'd be all 9 points there. How do we feel about that? Not too terrible? Why this? You want me to explain why the side length is 6 minus the function? Is that what you said? Sorry. Yeah, so let me put a new page in here, just since that was getting a little bit. That didn't turn out so great. There we go. Here's y equals 6, right? Here is y equals f of x, whatever our function was. And here are our squares projecting out of it. So our side length here ought to be the entire distance minus the distance from the function to the x-axis. That's our x-axis. So s should be 6 minus f of x. Does that make sense or no?
Yeah, that makes sense now. Thank you.
Cool. Yep. Part A for this one is not an area or a volume thing at all, right? We want to write an equation for the line tangent to the graph of f at the point where x equals 1/2. So in order to write the equation of a tangent line, what do we need?
Derivative.
We need a derivative to start with, right? Because the derivative will give us our slope. So f prime of x ought to be easy enough to find. It should be
24x squared.
24x squared. And we need to evaluate that at 1/2, which gives us what? 1/2 squared is a fourth, right? And the fourth of 24 should be
6.
6. And we also need, in order to write an equation of the line, not just slope, but we need a
Point.
exactly. So our point should be f of 1/2. What's f of 1/2?
1.
Should be 1, right? 1/2 cubed is an 8 times 8 is 1. So all we got to do is go in and write our equation. Y minus our y value equals m times x minus our x value. Easy enough?
Yeah.
Cool. That part of this question was worth 2 points. So 1 point for getting the actual equation here and 1 point for getting the value of f prime of 1/2. Good? All good? Everyone good?
Yeah.
Okay. Part B got a little more complicated. We want to find the area of this region. So the area of this region should be an integral from 0 to 1/2. Okay. X equals 0 to x equals 1/2. And it should be our upper function minus our lower function. And so our upper function is, which one is our upper function? Sine pi x or 8x cubed?
Sine pi x.
Sine pi x. Sine pi x minus 8x cubed dx. Okay, everybody good with that? This piece right there is 1 point. Okay. Then 2 points for having the right antiderivative. So sine pi x, we should be getting pretty comfortable with these very simple u substitutions. What does the integral of sine pi x come out to be? Should be negative 1 over pi cosine pi x. And what's the integral of 8x cubed?
Square.
Should be 2x to the fourth. I'm not sure what she said. I couldn't understand what she said, but it should be minus 2x to the fourth. And we'll evaluate that from 0 to 1/2. So having the right integral there is worth 2 points. So that's 3 total so far for part B. And then your final answer is worth another point. So if we plug in 1/2, we end up with negative 1 over pi times the cosine of pi over 2. What's the cosine of pi over 2? Zero minus, and then we add 1/2 to the fourth. What's the half to the fourth?
1/8.
A half to the fourth is 1/16. And then times 2 is
times 2.
Yeah. And then minus all of this evaluated at 0. Well, the second half of that is definitely 0. But what about this? Negative 1 over pi times the cosine of 0. What's the cosine of 0? Should be
1.
Right, so that should become negative 1 over pi. And if we simplify all that down, we end up with a positive 1 over pi minus a 1/8. And that is worth 1 point. So part B was 4 points, part A was just the 2 points. Everybody good with part B? Any questions on part?
Would we have still gotten 2 points if we had split it into 2 integrals?
Sure. Yep, if you split into 2 integrals, and then did you write out the u substitution for the first one? Is that?
Yeah, and I changed the limits of integration.
Yep, that's fine. Nothing wrong with that. That's not what they would indicate in the scoring, like in their scoring guide. They would just have the integral like that. But if you did it and had the right integral, so I mean, yours should have looked like negative 1 over pi cosine u. And your limits for that first part of it should have been what, from
0 to pi over 2.
0 to pi over 2, yeah. So as long as that's what you had, you're good. All right, and for part C, we want to write but not evaluate an integral expression for the volume if we rotate this around the line y equals 1. And so this should be pi times an integral from still 0 to 1/2. And it should be our outer radius squared. And so our outer radius extends from the y equals 1 line down to the lower function. This is our outer radius. And our inner radius, let's put a different color here. Our inner radius should extend from y equals 1 to our upper function. And so hopefully by now we're getting to the point where we're pretty good with revolving with this other line that's not the x or the y axis. And this is 1 unit for the entire thing minus the y value that I've got up here for my 8x cubed function. So it should be 1 minus 8x cubed to get the outer radius, and then squared, and then minus 1 minus my upper function, which was sine pi x squared dx. and the limits and the constant out in front was worth 1 point, and all of this was 2 points. Good or no? Any questions on that?
I have a question on part B.
Okay.
So the 1 over pi that you got from the u substitution,
Uh-huh.
so I messed up and put it on the outside of the integral.
Nah, yeah. You would be getting just 1 point then for part B.
I was wondering because well, I did it like in my head, so I don't know if I'm making a mistake in my head, but I kind of am having trouble seeing where I went wrong. Like, because is it not considered a constant in front and you can move it outside, or?
Well, it is, but it's not a constant. So you have, what was the other thing we had attached to it? Sine pi x, what was it? Minus 8x cubed.
Yeah.
Minus 8x cubed. So the problem is, if you do the u substitution with u equal to pi x, right, is what you did. Well, this thing in it doesn't have a pi x to substitute out.
Okay.
And so what you're doing is, if you're taking out the x's to turn it all into u's, you have to replace the x's with u over pi, which effectively would make this now sine of u minus 8u cubed over pi cubed.
Okay, I see.
And so you're not doing this. And so when you put in the, and this still will have a dx to it, so you had to multiply by a 1 over pi times everything. That's fine. Then you pull the 1 over pi out, but then you get a different thing here. So what, I'm not sure who was saying it earlier. Didn't mean to go that far away from there, but somebody was saying earlier that they did the u substitution, but they separated into 2 different integrals, right? Which is
Okay.
what you should do, because that way you don't have to worry about that, and you can just deal with the u sub here, and then the 1 over pi can be out in the front of just this integral, and that's fine. But over here, you can just integrate in terms of x. Does that make sense?
Okay, I see. So because the integrals are still combined, you can't take it out because it's only a constant to that part.
Yeah, effectively, yes. That's correct.
Okay.
Yeah, generally, if you're going to do a u substitution and the thing you're substituting out of part of the integral isn't seen in the rest of the integral, separate into 2 integrals first and then do the u sub for just the one you need to.
Okay, yeah. All right.
Good?
Thank you.
Yep, no problem. All right. We've got some more time here. You guys want to do a calculator or a non-calculator one?
Non-calc.
Non-calc. All right. Here is another non-calculator one, and we'll just keep going straight through with this. So I'll give you, I guess, about 15 minutes. We'll go through this one. We'll probably just go through this one on Monday then. But I'll give you guys the time right now to work on it. So please don't leave, even though some people have been leaving. Please don't leave, and stick around and finish this one up. And you'll note that part C is, once again, not an area or a volume thing. So ready, go.